Problem 7. Suppose that the cost in dollars for a company to produce X pairs of a new line of jeans is given by this function. Find the marginal cost. Remember, marginal cost function is the instantaneous rate of change of the cost. Instantaneous rate of change is called marginal cost function. So that is, it is derivative. So derivative of your cost function is marginal. So let's find the derivative of this. So that is 3 plus 2 times 0.01. So 0.02 x plus 3 times all of this 0.0006 times x to the power 2. So that is the marginal cost. So when I have to find marginal cost as at 100, I'll just plug in 100 for x. All right. Instead of x, I'll write parenthesis 100. Okay. All right. Now what about the cost? Find the cost of manufacturing the 101st. The cost of manufacturing the 101st pair of jeans is the cost of manufacturing 101 jeans minus cost of manufacturing 100 jeans. So I'm going to use this function. First plug in 101 here, then subtract. So you see 101 there. Whatever we get, subtract. Don't forget to use bracket after the subtraction. Put 100 in there. All right, 100 in there. So that's it. All right, next question. You are studying population of wolves and caribou. So wolves are the predators, caribou are the prey. All right, W and C in northern Canada. The interaction is given by this model. What values of dCdt and dWdt correspond to stable populations? Well, these are changes in population, correct? So if you want your population to remain stable, the change has to be 0. When change is 0, population is stable. Okay, so rates of changes have to be rates of populations with respect to time has to be 0. Now, suppose A is 0.05, B is 0.01, C is 0.05, D is 0.0001. After finding the population for wolves and caribou respectively that lead to stable populations, is it possible for the species to live in balance? Answer B for balance, E for extinction. Well, what happens? We know that the stable means derivative is 0. So derivative, we are given functions for derivative. So you take that derivative, set it to 0. Question is, can we solve for W and C meaningfully? Well, assuming C and W are not 0, I can solve for W, right? A and B are positive numbers. And I can find C and D. Using C and D, I can find capital C. So these are positive numbers. They are not 0, right? In other words, neither one of them has gone into extinction. So there is a balance. So you would put balance. Okay. So that completes section 2.7. Okay. So next videos will cover section 2.8. Until then, bye.